All right, geometry students, tonight our notes for Monday are over the distance formula. This is a topic that you have discovered before. We'll refresh our memories on how it works, and then we'll probably put it to use just like we did with midpoint, a little bit differently than maybe you've seen it done before. So let's begin. Okay, our objective today is the student will discover the process and applications of the distance formula. These notes are for Monday, September the 23rd, so please record that date along with your objective. Again, these notes will not take long, just like the midpoint did not take long. And as always, pause the video anytime you need and then press play when you're ready to move on. Okay, now review just like we started off last time. Remember that any location in a two-dimensional coordinate system has an ordered pair x, y that describes its precise location. And you've already got this in your notes from Friday, so you don't necessarily need to put it down in there again. But also remember, okay, if your point happens to line up with the negative x-axis, like this point does, that means you're going to have a negative value for your x-axis. And if it's a positive value on the y-axis, then it's a positive y. Okay. The rule for today, along with the distance formula, is going to be for any 2 points, point 1, which lives at x1, y1, and point 2, which lives at x2, y2, there is exactly one line segment connecting them. Okay, so we're going to get the same notation with the point 1 and the point 2 stuff. Okay, but today, obviously, we're not talking about midpoint. Today, we're talking about distance. That is a length. Length is typically measured on things like line segments. And here is the formula. You've probably seen it before. Okay, it's everybody's favorite gigantic radical. Remember, a radical is the big check mark thingy that you see in the equation here. That is a mathematical operation, just like addition, subtraction, multiplication, and division. And we will probably discover a different way to use it than you have before. But at any rate, the formula says distance equals the square root of the difference of the two x values squared plus the difference of the two y values squared. So x1 minus x2, quantity squared, plus y1 minus y2, quantity squared. If you need more time to copy down the equation, press pause and then hit play when you're ready. Okay, now here's a little diagram that kind of shows you what's going on with distance. As you can see in our diagram, we have 2 points, point 1 and point 2. It does not matter, just like with the midpoint formula, it does not matter which one is point 1 and which one is point 2. The formula does not care which. Okay, but the distance formula will measure how far away they are from each other in the graph. Now, I've heard some crazy things over the years that some junior high teachers have told junior high students. Things like you don't really need a formula to figure out distance. All you do is count all of the lines that you bump into on the graph paper, and that'll get you close enough. It absolutely will not get you close enough in high school. So if you did have a junior high teacher that told you that, it's time to forget it. Now we're going to use the actual formula. Okay. Now, also keep in mind, distance is a length. Okay. If it's a length, then we will always expect our answers to be positive. There is no such thing as negative length. Okay. It's like saying if it were 300 miles from Odessa to Dallas, does that make it negative 300 miles to come back from Dallas? Of course not. It's still 300 miles. It's just in the opposite direction. That is distance. Distance is always positive. Okay, so let's look at an example together, and then just like on Friday, I'm going to give you a couple of additional examples to copy down. You can go ahead and work through those examples if you feel okay with it, and then we will run through those examples, those two remaining ones, real quick in class on Monday, and you can verify if you did get them right. But let's start with this one. Find the distance between points 2, 3 and 4, 1. Now, we're going to follow the same procedures. What was the first thing we did with the midpoint problems? We're going to do the exact same thing with the distance. We are going to take our 2 points and we are going to label them x1, y1, and x2, y2. Again, how do you know which one is point 1 and which one is point 2? It absolutely does not matter. Just pick one and label it point 1 and label the other one point 2. Remember, each point gets an x and a y. x1, y1, x2, y2. What's the second thing we did with the midpoint? Every time we needed the midpoint formula, we wrote the formula down. We're going to do the same thing for distance. So we're going to write down our formula, the square root of the difference of the x's squared plus the difference of the y's squared. We're going to get in the habit of writing these things down because when we have all the information written in one place on our paper, all in one spot, we make fewer mistakes having all that together in one spot. Okay, once you have your points written down and labeled, and you have your distance formula recorded on the paper, now all we have to do is plug in the information exactly where the formula calls for it. So the formula is going to ask for an x1, that's going to be positive 2. Then the formula is going to ask for x2, that's going to be positive 4. y1 is going to be 3, y2 will be 1. So all we're doing is just a little simple connect the dots puzzle. There's really no reason or no explanation for not plugging in the values in the right place. Okay, now when you're working through the distance formula, okay, order of operations is a little sketchy. Okay, please excuse my dear Aunt Sally would tell you that you would need to work on parentheses and exponents first. Well, there's parentheses and there's exponents in here. Okay, but the general rule of thumb for please excuse my dear Aunt Sally is to go to where the problem is the most complicated and begin there. Go to those locations and try to please excuse my dear Aunt Sally at those spots. So the most complicated, the most tangled up parts of this problem is inside of the parentheses. So on the left there, we're going to want to deal with the 2 minus 4, and we're also going to want to deal with the 3 minus 1 before we do anything else. So on the left, what is 2 take away 4? That's going to drop us down to negative 2 on the axis, on the number line. Okay, what is 3 take away 1? That is also 2. So we get a negative 2 and we get a positive 2. Now, if you're thinking, whoa, 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 Mr. Hill, you said that distance can never be a negative value. And you're right, but we're not done yet, because look what's going to happen on this next step. On the left side, negative 2 is going to be squared. What does it mean to square a value? It means that that value is going to multiply times itself. So we're going to get a negative 2 times another negative 2. What is a negative times a negative? Negative times a negative is always positive, so negative 2 squared will be positive 4. And on the right side, 2 squared, 2 times 2, also 4. Okay, so here we have 4 plus 4 is obviously 8. Now, here's where things are going to get a little bit different. Your junior high teachers may have turned you loose with the calculator at this point in time. So you go to your calculator and you push square root of 8, and you would get something in the ballpark of 2.82 blah, 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 blah. It's an irrational number, meaning it doesn't repeat and it doesn't ever stop. Okay, the decimal point goes on forever. That forces us to round off our answer, and when we have to round off our answer, we made it inaccurate. Well, we're not really interested in inaccurate answers. We're interested in the right answer. So what we're going to do is we're going to learn how to simplify this radical manually. Okay, some of your teachers have shown you how to do this, some of you not. Okay, but let's do it now. What we have to do to simplify a radical is we have to factor the information that is underneath the radical. So we're going to take 8 and we're going to break it down into something times something else. Okay, so what can 8 be? Now, obviously, it can be 1 times 8, but that doesn't break it down. You still have the 8. We want to be able to tear it down into smaller numbers, something times something. Obviously, 8 can be 2 times 4. Okay, good. 2, okay? 2 times 4. Let's look at the 2. Can 2 be broken down any further? It can't. It's a prime number. So 2 is broken down as far as it can. But the other side of that, times 4, 2 times 4. Can the 4 be broken down any further? Yes, it can. What is 4? Can 4 be broken down into? 2 times 2. So 8, when it is factored, is actually 2 times 2 times 2. Now, why go to all of the trouble to do this? In order to get stuff out from underneath a radical, you have to have pairs of a number. Okay, well, look underneath the radical. Do we have 2 of anything? Sure we do. We have a pair of 2's. Actually, we have 3 2's, but we do have a pair. Okay, 2 of those 2's can join together, and they can come outside of the radical. Okay, that's how we simplify. We want to get stuff out from underneath the radical. So 2 of the 2's are going to join together and come outside of the radical, but 1 2 is going to be stuck underneath the radical because it didn't have anybody to pair with to get out of there. So our answer, square root of 8, it is not 2.82 blah, 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 whatever the calculator says. The square root of 8 is exactly 2 square root of 2. When we do anything that deals with radicals in geometry this year, we will not use the calculator. We will not get a decimal point from the calculator, round it off, and write that down. We will simplify the radicals manually, like we just did, and we will record that answer. Okay, now it'll take a little bit of practice, so if this is the first time you've seen it, we'll get another example or a couple of examples in class on Monday, so hopefully you'll get a little bit more familiar with it then. In the meantime, I'd like you to go ahead and copy down the next 2 examples. Okay, these will be the ones we will go over in class together. Okay, so copy down what is the length from A to B if A is at 0, 6 and B is at -3, 2. Okay, copy it down, and if you feel confident, go ahead and give it a try. We'll work over it in class. That way you'll be able to see if you got it right or not. Go ahead and press pause, finish writing down the problem, and then press play when you're ready to see the next example. Okay, the third example, again, in the English language, there's a lot of different ways that the same questions can be asked, so here's how we're going to ask the next one. What is the length of the line segment connecting A and B? And then instead of being provided with the information, we are going to be given a graph. Okay, so again, copy this one down. If you're feeling okay with it, go ahead and work it out. Okay, if not, we're going to go over it in class on Monday. Okay, so hit pause until you're done. But that is it. That is all that we're doing on the distance formula. So I hope you're having a good weekend. I appreciate you taking time to get your notes copied. And for those of you that got your projects in, I do appreciate you getting that taken care of. That should work out to be a good test grade for you and help those 6 weeks averages. Also keep in mind that this is a short 6 weeks. It's only 5 weeks long. This coming Friday is the end of the 6 weeks. We need to get some stuff taken care of. Wednesday will be the last day that I will accept grades for the first 6 weeks. So get it done. You got about 3 days.